Good morning, this is Michael O'Malley. In today's video, we will be discussing Hurricane Isaias and the data collection efforts that I was a part of. If you guys do want to go check out more about the type of data collection that I'm doing, make sure to click the eye in the sky in the top right hand corner and check down in the description down below for a video link to my Hurricane Landfall project cameras. There you will find all about what I'm doing and my intentions for deploying these cameras in front of landfalling hurricanes to better collect data and help safety evacuations and efforts. Without further ado, let's begin. Hurricane Isaias developed from a vigorous tropical wave that came off of Africa, dubbed Invest 92L a few short days after leaving the Cabo Verde Islands. 92L then became a potential tropical cyclone at about 1500 UTC time on July 28, 2020, later becoming a tropical storm near Puerto Rico, Hispaniola, and the Dominican Republic after moving into a more favorable environment with less vertical wind shear and more moisture to work with. In the coming days, Hurricane Isaias would be born. For this video, we will discuss mainly Florida impacts, as that is where I'm based out of and right now able to collect data at. Florida's worst impacts came during August 1st through August 2nd as tropical storm force winds reaching nearly 50 miles per hour right along the coast and some squalls that produced tropical storm force winds inland as well, while the strongest winds remained offshore by about 15 or 20 nautical miles, give or take. Here you're looking at the uprushing heat content associated with this system. The greens, yellows, and oranges are higher uprushing heat content values, and the higher you go in the scale, it supports generally stronger tropical cyclones. In the gray here, you can see right where my laser pointer is. This is where the tropical cyclone was expected to track. This is a couple of days before marching into the Carolinas. But you can see the general track right along the Florida East Coast and then expected to gradually take that northeast turn and move rapidly off towards the north and east. Notice these generally higher uprush heat content values right near the coastal waters of Florida. For Orlando, this is the Orlando data, the rainfall and station pressure. This comes directly from my own personal weather station that I have and set out in front of Isaias to capture all of the data there. You can see our pressure is marked in blue while our rainfall here on the second axis is marked in orange. The pressure is over here showing our lowest pressure of about 29.75 inches. That's roughly about 1,008 millibars or so. And then you can see our rainfall during our pressure drop. This is about 7:30 a.m. Eastern time, about on August 1st. And you can see kind of where we go. We have a little bit of a dip here, and then it really starts to fall off here. This is also when we had an increased rainfall between about 4:30 in the morning and about 7:30 in the morning. Then roughly from about 8:30 all the way up until about 10 o'clock in the morning, we had sufficient rainfall topping right near 0.06 of an inch, or a little bit more than half an inch of rainfall. But you notice our pressures generally then began to fall to our lowest point here, which was roughly about 1,008 millibars with no additional rainfall before finally peaking up here as the cyclone began to move away. Here is the Melbourne data. This comes courtesy from the Melbourne airport in the METAR reports there. The pressure is plotted in blue and the wind is plotted here in orange. And you can see our pressure. Again, this is basically what you're looking at for your hectopascals here and your pressure data. Our lowest point here was about 1,001 millibars to right around 999 millibars here at about 6 p.m. Eastern time on August 2nd. You can see our wind report, our wind data here suggesting that we got up to nearly 50 miles per hour before finally dipping substantially down here. And by 12 a.m. then on August 3rd, our wind speeds here were generally right about 10 miles per hour, with our pressure now beginning to rapidly rise as the center of Isaias is passing over and away. Here's an animation based on Tropical Storm Isaias to point a couple of things out before the animation begins. These darker reds in here, this is your tropical storm warnings for the coastal communities. Your lake wind advisories issued by the Weather Service Office in Melbourne are in your tan colors. Your yellows here, this is indicative of your wind radii from about 40 to 59 miles per hour, where your 60 to 70 mile per hour gusts here are in your little bit of a brighter red color here, and you can just watch how this evolves. And as you can see, the strongest winds continued to be confined just offshore before finally taking more of that north-northeast bend and away from land. Again, tropical storm reports were flooding in from along the coastline. Some wind damage occurred as part of this, but the most impacts were right along the coast. Not many impacts were felt here well inland, especially into western parts of Orange County, western Seminole, eastern parts of Lake County only had some brief rainfall from it. The further inland you went, the story was pretty much you don't really get many impacts from this. This was mainly a coastal confined event for. This is the Melbourne radar. This comes from Mark Missenbaum over at Florida State University. This is at 16:17 Zulu time and then 17:45 Zulu time. You can see the rain bands here that we're working in from Orange County over then inland here over portions of Sumter, Highlands County, over there, Polk, and then eventually up into North and West Florida. Our center of circulation continued to be right about here, and our mid-level center was here. You can see that here. In the 1745 Zulu time radar, the low-level center was displaced due to vertical wind shear, but you notice how those squalls were affecting pretty far inland over all the way to near Tampa and the Gulf of Mexico there. And then this is right about 2200 Zulu time. This is nearing the peak wind gust reports here from Melbourne. And again, our low-level center is positioned right at about here. Our mid-level center is about here. But again, you have these squalls that are coming in and wrapping around here. And that created some pretty good gusty winds up to near 50 miles per hour near the Melbourne area and just south of there, immediately along the coast here, along the Treasure and Space Coast, got roughly about 50 mile per hour gusts. But the further north you went, especially northern Volusia County, did not get much at all. And that is Volusia County right there. That is Flagler County right there. Flagler County actually didn't really get a lot of impacts from this in terms of gusty winds. This is the forecast graphic I made, valid as of 7 o'clock Monday morning. Again, you're basically looking at the synoptic scale features here of Isaias as was beginning to pull away from Florida. We had a big trough of low pressure that you can see clearly here highlighted in yellow with the trough axis located right around here. Your ridge was positioned right about here, and that was allowing just a little bit of a tug off towards the north and northeast here before coming into the Carolinas. The shear vectors were better aligned. The shear was out of the southwest, and for the longest time that was holding back the system because it was pulling in a lot of dry air. But that's one of the things that allowed it to intensify quicker into a pretty formidable Category 1 hurricane upon landfall in North Carolina, is that this was now beginning to align itself better with the shear vectors and also getting a little bit more help from the poleward extent of the outflow that helped to better ventilate the storm and close off an eye wall. This is the visible satellite loop here from August 2nd. Again, you can clearly see where most of the convection was pretty well confined to right along the coast. Here you had substantial amounts of deep convection right along the coast and even well into portions of Grand Bahama Island and Freeport and even all the way over to Marsh Harbor and the Albacoa Islands over there. But again, as in terms of the Florida impacts right along the coast, you had your worst impacts coming from this exposed low-level center that you can kind of see right located in through here, and then our mid-level center was roughly in through about here during that time frame. So thank you guys all for watching. I greatly did enjoy making this and putting this all together. If you guys do want to see more of this, I will have more on the way, going over Hurricane Irma back in 2017 and Hurricane Dorian in 2019 and going over those. These are my sources and credits for the wind and data collected. This was all put together by me. For the radar is courtesy of Mark Missenbaum over at Florida State University. Satellite and upper ocean heat content maps were courtesy of Colorado State and the RAMMB website. Plots created on the second slide using Python 3 and Tropical, and the forecast graphics were created by me with the help of AWIPS 2. Thank you guys all for watching. I will catch you later this afternoon with my hurricane outlook and discussion. If you guys want to see more, please let me know. Otherwise than that, have a great rest of your morning and early afternoon. I'll talk to you again some more later.